There are a wide variety of ground resistance testers available on the market today. These vary in design, features, and complexity, and include small handheld models as well as larger field instruments that are often packaged as part of a complete kit. These products also range in price from a few hundred up to several $1,000s. In this video, we discuss several critical questions to consider when selecting a ground resistance tester. Our goal is to help guide you in choosing the instrument best suited to your specific application and requirements. The first, and probably most important question, is whether your current or future needs require soil resistivity testing. For example, if your work involves the design and/or installation of new grounding systems, soil resistivity testing is a necessity. An instrument designed for four-pole testing, also referred to as four-point testing, is required for this application. A basic low-cost four-pole tester provides measurement results in ohms. You can then use this reading to manually calculate soil resistivity, which is usually expressed in ohm centimeters or ohm meters. More sophisticated instruments include a built-in formula for calculating soil resistivity using the Wenner or the Schlumberger method. If you regularly need to perform four-pole testing, consider purchasing an instrument that automatically calculates soil resistivity. This will save time and eliminate potential math errors. Assuming you do need to perform soil resistivity testing, the obvious follow-up question involves the types of grounding systems you will test. Will this include small systems, such as residential, or larger and more complex systems, such as commercial, industrial, telecommunication, or electric utilities? To illustrate the importance of this question, let's consider a typical small site with a grounding system consisting of a copper rod driven into the ground and connected to the service entrance. In this illustration shown on the screen, if the house has not yet been connected to the power line, a basic three-pole ground resistance tester, or a four-pole instrument configured for three-pole testing, will suffice for measuring the resistance of the house ground rod. If the house has been connected to the utility, a clamp-on ground resistance tester can measure the house ground rod resistance. If you choose a three- or four-pole instrument for this, one point to bear in mind is the distances required for auxiliary rod placement. For example, performing a follow potential test on a single ground rod driven 8 feet deep requires at least 80 to 100-foot test leads. If more ground rods are present, the distance requirement increases. Ground resistance test kits are available from AEMC that include the measurement instrument, the auxiliary electrodes, and leads. Lead lengths provided in these kits are 150 feet, 300 feet, and 500 feet. We suggest selecting a ground resistance test kit with leads at least one size longer than your immediate need. So if 150 feet is required, a kit that includes 300-foot leads will provide a good margin of error. For larger sites with multiple rods or ground grids, consider kits that provide 500-foot leads. A related question is whether the soil resistivity is high in the area that you will be testing, or whether the distance required for the auxiliary rods to perform follow potential testing is unusually long. If the answer to either or both of these questions is yes, and you intend to perform follow potential testing, you must consider the instrument's injection current and test voltage. Typical injection currents range from a few milliamps up to a couple hundred milliamps. High soil resistivity usually produces high contact resistance for the auxiliary electrodes. This can be of concern when using lower cost instruments that typically provide 10 milliamp test current. So in these circumstances, we recommend a four-pole instrument capable of delivering higher test current. Before we leave the topic of auxiliary electrodes, note that clamp-on instruments do not require any auxiliary rods or leads. Another advantage is that you do not need to take the grounding system out of service to perform the test. Another subject to consider is whether electromagnetic interference, or EMI, is present at the test site. EMI can result in unstable or inaccurate readings, particularly at low test frequencies. The most common test frequency is 128 Hz. Instruments that feature automatic test frequency selection can find the cleanest available frequency, which provides an advantage in high EMI environments. Clamp-on instruments can also be effective in such locations, since they typically test at higher frequencies. Newer clamp-on models available from AEMC also offer test frequency selection. Note that in some high inductive environments, lower test frequencies can produce more reliable results. The choice of instrument can also depend on how you intend to use the data you obtain. For example, if you plan to save, analyze, and distribute your test results, data storage and report generation become important considerations. Newer and more advanced instruments, both 3- and 4-pole testers in clamp-on models, can store test results in internal memory. This data can then be downloaded and analyzed using software running on a computer, or via mobile apps for smartphones and tablets. This can be a very powerful tool for contractors conducting tests for clients. An added advantage for a mobile app is the ability to immediately send test results as an email or text message. Finally, if you're planning to test complex grounding systems consisting of many components including a ground matter grid, you will need to test the continuity across the bonding between the various elements. This test is most often conducted using DC voltage and current. Several ground resistance testers provide this capability with test currents up to a couple hundred milliamps. In addition, a more complete test can be performed with a micro-ohm meter. The advantage in using this instrument is its ability to test at higher test currents, up to 200 amps. This can expose problem areas not always revealed when testing with milliamp range currents. Whatever your ground resistance testing needs, AEMC has an instrument that meets your requirements. If you need to perform basic ground resistance testing with no soil resistivity testing required, consider the AEMC ground resistance tester models 3620 and 3640. Both instruments measure the resistance of grounding systems via the 2- and 3-point methods, and both feature simple one-button operation. The model 3640 also provides auto ranging. Each instrument can be purchased standalone or as part of a kit that includes leads, auxiliary electrodes, and other accessories. In addition, the handheld clamp-on ground resistance tester models 6416 and 6417 measure ground rod and grid resistance without requiring auxiliary rods. To perform basic ground resistance testing with 4-point soil resistivity measurement, the AEMC models 4620 and 4630 are good choices. Each instrument is rugged, easy to use, and can be purchased standalone or as part of a complete ground testing kit. For ground resistance testing with high soil resistivity present, you need an instrument that can inject test currents greater than the 10 milliamp current typically provided by lower-cost instruments. The models 6470-B, 6471, and 6472 provide test currents up to 250 milliamps. These instruments also offer a number of other advanced ground resistance capabilities. If you have a need for testing continuity across the bonding between components in complex grounding systems, you'll also require an instrument that can inject higher test currents. In addition to the ground resistance testers shown on the screen, AEMC offers micro-ohm meters that can be used in this application. For example, the model 6292 with test currents up to 200 amps. For ground resistance testing in high EMI environments, the best way to minimize these effects is to use instruments that automatically select the cleanest test frequency for the environment. The models 6470-B, 6471, and 6472 provide this capability, as do the models 6416 and 6417 clamp-on ground testers. Note that the models 6416 and 6417 are the only clamp-on ground resistance testers on the market that offer test frequency selection. If you plan to perform high-end ground resistance testing, including pylon testing, AEMC's GroundFlex Field Kit is your best option. Pylon or tower testing usually requires disconnecting the overhead ground conductor, a time-consuming, expensive, and potentially hazardous operation. The GroundFlex Field Kit offers the unique capability of testing pylon resistance without disconnecting the overhead ground conductor. The kit includes the model 6472 as well as the GroundFlex adapter model 6474, and comes with all the sensors, leads, and other accessories needed to perform pylon testing and other ground resistance testing applications. And if you want report generation capability, AEMC's free Data View software enables you to download test results from the instrument to a computer. You can then generate reports from this data using templates provided with the software or custom templates you create to suit your specific requirements. These reports can be analyzed, shared, and stored for future review. DataView supports the models 6470B, 6471, and 6472. It also supports the model 6417 clamp-on instrument. A free Android app is also available for interacting with the model 6417. Let's take a moment to review. When deciding which ground resistance tester is right for you, consider whether or not you need an instrument that can measure soil resistivity. If so, think about what types of ground systems you are likely to test. Take into consideration the environmental factors at your potential test sites, such as high soil resistivity or EMI. Also bear in mind how you plan to use the measurement data. If you need to test bonding in complex grounding systems, consider an instrument that can perform continuity checking with high test currents.